Welcome to the shop. So, we're playing around here. Got a hot mess everywhere. Whatever. It is what it is. So what we're looking at doing is we're looking at converting this cheap Harbor Freight vise into a way that we can test pliers repeatably. I don't know how this is going to work out, but we're going to give it a go. So what the idea is to make custom jaws that we can put pliers in and squeeze them with the vise and make the same pressure over and over again. So we'll make custom jaws to kind of cradle the contour of the plier handles so that we can get them to sit in there reasonably decent. And what we should be able to do is crank the handle of the vise here until we get the same reading, or we get the reading at what the cutter cuts, or maybe we work with a crimper and we squeeze it to the same pressure and we see which crimper crimps better with the least amount of force. There's a few things we could play around with here. So what the theory is that if I take off this jaw, high quality Chinesium, and modify the base of the vise here, I've got this load cell summing box that you see here with the digital readout, and I have these two mini M18 load cells. And what I like to do is tap the vise out to this size fastener and put them in. So now, like, if we start compressing these, you can see that one is me squeezing that side. If I let go of that, we should go somewhat back to zero. And then I squeeze this side, we should go somewhat back to zero. And then if I squeeze this side and then squeeze this side, you can see we're adding. So they're working together, and what my thought is we'll set that in like that, have our wiring come out. So we'll have our two load cells, and we'll set the new jaw on these. And we'll make some sort of box to put the summing box in. We're also going to use, not this is charging the camera because the camera battery's dead, but we're going to use a Chinesium version of the inverter to power the summing box. Mainly because I'm just not set up to have cords strewn everywhere, and we'll probably design the box that it'll plug in and or use the Chinesium inverter. It's just options in life, so that's kind of what we're looking at. But I think what we'll do, now that we've tested and we've proven that our summing box is working, we can start modifying the vise. So I've already taken the one jaw off here in preparation for this, and what we'll do is start laying out how we're going to inset these, and I think I'm going to go something like this. This is a 6-inch vise, so we should have a decent travel to get a pair of pliers in the jaws with the new jaws. Now for the new jaws, I got some bar stock. It's going to be up a little bit higher, and that's okay. Doesn't really matter. And we'll grind out the inside of this so that the plier handles will sit in a contour. I guess you get what I'm getting at here. We'll create a contour there that the plier handles can sit in, and maybe we can get some repeatable results there. So it's the idea, and we'll see if the idea can work. So we just got to start butchering this thing. So what I'll do is I'll get this vise taken apart. The camera is currently attached to the vise because I didn't have anything else to put the camera mount on. That's just the way it goes sometimes. But we got a theory. We're going to play around here, see if we can get these mounted in here. I don't know if I'm going to show all this. This is really just going to be drilling and tapping. I have from McMaster, I bought the proper size metric drill. Right there we have it. For the M8 by 1.25 thread pitch, and that's what the load cells are. So we have some taps, we have the drill for the taps. I mean, maybe I'll show some pictures or something, but you guys get the idea of drilling and tapping. We'll drill this out, tap it, and I think what we're going to have to do is grind some of this out, because this has a ledge. I don't know if you can quite see it, but this is cast into the vise base, and then the jaw kind of cradles on that. So I don't think I want to get rid of all of it, but I will get rid of a radius where the load cell is going to hit it. So it won't, the load cell would not, as it is right now, go all the way in like this. It would stick out a little bit because of that ledge. So we're going to grind out some of that ledge so we can get the load cells all the way in, and we'll see how that works out. So we'll play around with some of that. It might have to get a little bit bigger. I'm just looking at right now because of this connector, but we'll see what we can do. See what we can get together. This operates on 120 volt AC or 220 AC, 240. We're going to rig it for 120. We're going to verify the low voltage shutoff on our Chinesium inverter. I'll pull that over, but the display will probably go out because the plug's loose. We're probably going to hardwire it. Yep, there you go. Here's our Chinesium inverter. I'll hold it upside down. I was just kind of curious to see how these things work. We'll double check how the low voltage shutoff works on it and all that. The plug on this thing is super janky. I don't think I trust it. So what I'm going to do is I'm probably just going to hardwire it. We'll take this thing apart and we'll hardwire it. It'll be alright. So that's the idea. We'll see if we can start playing around with it. So real quick, we'll take a look at this Chinesium inverter. It's designed for 200 watts, they say, of 120 volt AC. And here's your multi-continental, various, everything fits in plug. And it really is kind of janky. It doesn't work very well. So it has USB and USB-C, much like the counterpart over here. And this one's got a fancy light on it, but we don't really care about that. So I think what we're going to do is we're going to see how this comes apart. Got some screws likely right there. Before I take it apart though, I will use the power supply, and I just want to see where the battery management cuts off, just so I know if I can trust this to not destroy batteries. Whenever you buy cheap Chinese knockoff stuff, it's always good to try and see where your low voltage cutoff is on the tools that you're using. The Milwaukee branded stuff is almost always at the right spot to protect the batteries. If you dip them too low, they won't charge. So if there's no battery management, I'm pretty sure that the listing of this said it has battery management, but just because it has battery management doesn't mean it's tripping at the right spot. So we will take this apart. Well, first we'll check it with the power supply, and then we'll take it apart and see if we can get a connector in it or something like that. I got to think about how I'm going to design all this to incorporate this and everything else. We might even make something that attaches to the vise. This vise is going to get butchered for this purpose. I don't care if I drill and tap into it. I may even drill and tap into this to make a custom camera mount. I don't know yet. So all I'm trying to say is, this is a cheap vise. We're going to drill it. We're going to attach stuff to it, and we're not going to really care about it. So here's our power supply. Here's our summing box for the load cells. And we just talked about mounting the load cells. So let's get into playing around with some of it. Okay, so you may have noticed things have changed. The vise is mostly disassembled. There's only one or two things left in it. We took the main clamping part out. I don't know the name of it, but you know what I mean. This is just the base. It's clamped in another vise, so we can work up here. So what we're going to do, I don't know if I'm going to video it because I won't be able to drill and see what I'm doing at the same time. But we have a drill bit. This is our pilot drill for the M8 tap. And what we're going to do is I made a tape stop. We're going to drill down to our tape stop in these existing holes. And then we're going to get out our M8 taps. And we're going to tap the hole and then see how we got to modify it to get the load cells in. So let me get these holes drilled and we'll check back in. Okay, so we've got our 6.7 millimeter holes drilled. I really only had to drill it slightly deeper. The existing holes were mostly the depth I needed. So now what I'm going to do is I am going to take a regular starting tap here. See how this taper is much less aggressive on this one. Here's your... Most people end up with this tap when they buy taps. This is a less aggressive tap. We'll start the hole with that, and then we'll finish it with the bottoming or plug tap here at the top. So we'll start with this, and we'll finish with that. And we're back. So we've got our holes drilled. Let's see if I can shed some light on that. Okay, so we've got our M8 holes drilled and tapped. And you'll also notice we marked the arc that the connector on our load cell is going to be on. So what I'm going to do is, well, we already made the first cut. We made a cut along here with the portaband. We're going to cut this ledge off. Also cut it over here. You can see I just kissed the face here. It'll be alright. And then what we're going to do now is clean that up with a grinder. Just cut that, clean these up, get these pieces off, round everything up, spin our load cells in, and we'll be back at that point. And we're back. So now we've got our load cells screwed on, and I would have preferred to have both of the connectors facing down, and I may do that yet. I don't know. This one's kind of loose in the down position. It wants to tighten here. They don't sit at the same plane. If I back this out, it's lifted off. I don't know. We'll see. But this is the idea of what we're working with. So then we're going to have our jaw that's adapted for the pliers. We'll bolt on here. And I have... Wait for it. And I have some rounded nuts that I think we can inset into our new jaw. We should be able to turn them in and tighten that. So we'll give that a go. I don't know how it's going to work, but they are the right thread for the load cells. And if we could tighten that up, have that all inside of our new jaw, that would be nice. That would be a pretty nice install. We could drill a clearance hole for that, tighten them up, pliers or something like that, and have everything in. So I may have a wire sticking up, which I don't really like, but sometimes that's the way things go. So we got this far, and now we got to look at making a jaw. So we'll cut a jaw down, get these centers transferred, and then we'll drill the holes and see how it sits on here. And we'll just start getting all of our pieces together, and then we can figure out how far down we got to drill to inset these, and then we'll look at dishing everything out for our pliers. So, progress. Alright, so we're continuing work. You probably just saw we test fit. What we're going to do is we're going to use a ring. Now this is the wrong length one. I have the right one on order. This is just one I had here in the shop. We're going to use a ring just like this. It's a safety ring with a spring detent. And what we're going to do is we're going to shove that through the vise jaw. This one doesn't go all the way through to the ring. And we're going to cut in the jaw lower a spot. And the theory here is that we can put these crimp connectors. I want to center them up on the load cells so that I could just do it this way and we could pull on the pin to test the strength of the crimp. But I'd like to center it up on the load cells. So I think what we're going to do is we're going to take a grinder and score the inside of the vise jaw so we can slide that in. You'll see here in a second, but I want to deburr this here first. Now a nice deburring tool, these things work nicely. This one in particular happens to be a Milwaukee one. If we can focus, there we go. This is a Milwaukee one. These things work pretty nice. You just kind of run them around like this on the surface, and sometimes you gotta go the other way. And all it does is get rid of any burrs that you have. Now, if you have something left behind like I do there, you could escalate the situation. And you could use one of these. This particular one's made by Irwin, and they're just kind of an all-around reaming tool. And what you just do is you chuck this up in a drill, and you come in and drill that. So that's what we're going to do here. Since we got a burr left behind there, we'll clean that up, and we'll flip this in the vise. We'll clean up the other surface, and we'll figure out where we'll put the cut. So here we go. We have everything in our trusty Black & Decker adapted drill, and let's see what we can do. And just like that, you don't need to do a whole lot. We got deburred, and we'll do this in real time. See if I can knock the camera off the vise. Turn that around, and we'll just sort of get it on there. And we'll just do the other side here. Just like that. Now you heard that kind of skipped a little bit there. I didn't have a lot of downforce. They can skip on you, but we deburred that. And this, as a result, this should go in much easier, and it does. So that burr on the top makes that ball kind of jam. But now that we deburred that, this pin goes in and out a lot better. So that's good. Now let me reconfigure things and we'll take a look at the other side here. Okay, so before I clamp this up in the vise, you can get an idea of what's going on here. We have a center mark in the plane of which the hole is, and then here's the center of our vise jaw. So really all we're going to do is we're just going to hit it and test, hit it and test. We're going to take a die grinder, and we're just going to start grinding. I think I'll probably use a 1-inch wheel to keep it as small as possible. And we'll just keep die grinding straight down until we clear the hole enough for one of these to sit inside here, right there. We'll see how it works. What we're going to use is a 1-inch die grinder tip here. And we're going to go at it just about like that. Try and square everything up as best I can. This is thicker than the crimps are. Not exponentially. Well, I guess so. It's probably 2 to 3 times as thick. I'm okay with that. It's not going to really matter. It's not going to sit here and do this. I just want to make sure we have enough for future shenanigans, because there are other crimps that are thicker than what we have there, and I just thought that it might be a good idea to make this compatible with that right off the bat. So let me get this in the grinder. And what we're going to use is the new version of the Milwaukee Dremel tool. Most notably, the biggest thing is the locker here. That seems to be pretty nice. I wish the old one had that. So let's get this set up on here, and I will be right back. Alright, so here we go. We have everything set up on the die grinder. This is an 1/8 inch collet, so we have an 1/8 inch tool on it. Always make sure these are tight. These new die grinders have a brake. When you turn it off, it stops. So that being said, this will come right off on you if it's not tight. I know some guys say, you don't have to kill them. When you're running the tool, it tightens itself. I would say with these new tools, make sure they're tight, because the inertia from this, it'll loosen. So that being said, let's make some sparks. Well, that was interesting. I think the tool was just beeping, trying to figure out what's going on. I don't know if it's that I'm taking too big of a cut for it here and it's unhappy, which is possible. I mean, that's a pretty serious cut for a tool like this. I am pushing it pretty hard, but it is a new tool. The other thing could be that we are showing 2 bars, but we very well may have been nearing a dead battery, and it might have been telling me. Okay, that's interesting. So let's just continue on like we didn't see anything, because that seems like the responsible thing to do. Now let's just see if the battery dies, or if we get a tool overheated. It doesn't feel warm, so I don't think that's overheating. Let's see what happens. Okay, so you may have seen through the hole that's just visible right there that we've poked through into our hole, and we just need to keep walking this down. Now we are going to get into this, and we are going to get into this. Now what I'm going to try and do is keep everything, you can see about what we're going for here. I'm going to try and keep this slot, which isn't perfectly square, unfortunately. That's just the way it goes when you're fighting with a camera and everything else. We're going to try and keep that as close to this side as we can, I think, because we're not really compromising anything if we come at it this way. I don't want to get this too far into here because we might mess up our handles. So I'm going to favor this side and kind of go in. If I have a notch in this bore, we just have that nut that goes in there. We can ream that out and not have any issues. The tightening face is down in the bore there. So I think that's what I'm going to do, since we just got through into the hole that we're going for. So let's keep going. So here's where plunge cutting with one of these grinders gets a little goofy, because obviously we have grinding wheel left here, but I don't have enough for what I need. So this is going to have to come off and go on the pile for use it later. We'll put a new wheel on, keep going down. Our goal is going to be to get this, that we can get that crimp connector in there far enough that we can pin it. So I probably will reset a few things here so I can get the pin into this hole and we can test fit things. So let me change the wheel here and we'll be back. And we're back. So I decided to get a little bit more daring and we put the 1.5" wheel on. Because we're offset, we should be able to get down in here, not kiss this side. And my hope is by the time the wheel wears down and we get down into this, I should be able to be deep enough to get the crimp connector in. Whole bunch of things going on, but let's see if it works. Plus we're going to work this Dremel a little bit harder. See how it takes it. Always be a light touch when you first start one of these death wheels. And have your safety glasses on. Easy, slower, faster. And we killed the battery. So looking down in the cut here, you can't quite see it yet, but we are just about through all of this hole. So the crimp connector is just about in, but not quite yet. So we have a little bit more to go. That's okay. We're starting to get into this a little bit. I'm alright with where we're at. I just don't want to be all the way down here. And we're just going down the main part here. We're not to the clamping surface of the nut. So we're still good there. I know you can't see any of that, but just giving you an update. We got 2 bars on a battery. Let's see what we get. I think the noise I heard was the drive in this grinder adjusting the speed, because I had loaded it and lifted out, and I think it was trying to find its speed. I think that's what I was hearing. I don't think there's a audible speaker in here. That wouldn't make any sense. So anyway, let's have at this. Okay, I pushed down pretty hard on that for a Dremel. And let's see where we are at. Oh yeah, we're getting there. We got about another 3/16 to quarter. That's good. So we're getting there. See, there you can hear that. That's, I think, the drive trying to figure out speed, and you just heard it level out. I think that's the drive. And we're at the stage now where we cut a little, try a little, cut a little, try a little, and that's okay. Oh yeah, we're getting close. So I gotta walk that over this way a little bit and down. Let's just see how much wheel we have left. Ooh, she's gonna be close. Yeah, well, let's give it a go. Okay, I think I'm going to have to change wheels just because I don't have the throat depth here. Oh, that is... yeah, we might get away with it. We are very, very close. Now, I laid into that on purpose there just to see if I could make it do that noise, but I could not. I think that will go. Let's blow that out with some air. I've been using these air nozzle thingies just because it's easier than starting a compressor up sometimes. So there we go. I think we have that through. Put our die grinder right there. And let's see what happens here. Crimp in position. I guess I should dry fit that. Dirt always goes in these holes when you start doing these things. And we're close. I don't think we're quite there yet. You can see I'm hitting, maybe not. Visually it looks like it should go through. There we go. So it's probably a little tighter than I would like. So I may hit that a little bit. I'm just wiggling that and we're going to see where the wear is. I think it's kind of... Let's try the other one here, because these things aren't all made equally. We have our non-insulated one. Yeah, I think the non-insulated is going to want a little bit more ground out. We're right there, so we'll change the wheel one more time, go down just a hair more, and I think we'll have it. What I'll probably do here is we'll hit this with the grinding stone just one more time and clean any burrs up on any of this so we don't hurt the handles on our tools. I will be back. Okay, brand new wheel, ready for some carnage. Try not to get my hand in the shot. Alright, got some more cleaned out there. Let's see what we get. What I want to see is the back side of this crimp, or I should say the top side, which I do a little bit on the insulated. Let's see how we look on the non-insulated. Now if I go to test any square crimps on this, I might have to rotor-rooter this out a little bit more, but we'll deal with that when we get to that testing. There we go, and that's got some nice flop to it there. Not a lot because it's in the pin, but I can tell it's not bound. It's exactly what I want. Let's test the insulated one. There we go. That's exactly what I wanted. So now what we should be able to do, because this is in between, it will favor this one more and it'll cock a little, but everything will be equal. So it might not be an exact reading, but if we want to test crimp connectors, we should be able to put a pin in like this and back the vise out and be able to test crimp connectors, how well the crimpers crimped, if that makes sense. It's kind of what we're driving at here. Because at some point these things are going to fail. We would either pull out the wire out of the crimp, or the crimp catastrophically fails, or something's going to happen. So the mating vise jaw is going to have a pin just like this, and we'll have a short piece of wire crimped with, we'll likely do an insulated and a non-insulated, and then we'll see what fails first, and you know, we'll play around with things because there's some age-old debates on what's better. So anyway, we'll have some options. I'm pretty happy with this, other than my grinding slot isn't perfectly square, but such is life. So speaking of grinders, the grinding stone, we're going to be using the new variable speed grinder. Picked one of these up just for this because I wanted to be able to change the speed. This also has a locking button on it, which is just awesome. So here's our old stone from the work we did here. We're going to get that changed and give this thing a run. Okay, so we got our new grinding stone on in the mandrel. And let's see what we can do. So there we go. I don't know if you can see that too well or not. Kind of hard to hold everything just right. But I'm pretty happy with that. Let's get that out of the vise and we'll take a look at it. Okay, so you can see we're crooked here on that. So be it, whatever, it's fine. This is just kind of horseshoes and hand grenades type stuff at this point anyway. Largely, we're looking for proof of concept, and honestly, if we're pulling on that, it'll be on wire. If it's a little crooked, it's not really going to matter. We know our pin's a little short, but that's okay. We got new ones coming. But the pin will go in just like that and sit in the vise. And this I have on an uphill, slight uphill angle on purpose. I'm hoping that it'll help hold the tool from wanting to fall down. That's the theory. We'll see if that works out. So that's the first jaw. We kind of need to match this for the second one. And I don't think that'll be too bad to do. We should be able to mount this jaw on the vise completely now. And this side of it should be done. Then we can get the other one of these made. And then we can start looking at mounting everything and building the wiring and do all that stuff. So, getting some progress. So I don't know if we showed this too well yet, but here's our custom screwdriver that we made. We had to grind this thing down pretty good to work out for us. But this is just a Craftsman screwdriver. These are okay screwdrivers. I don't know. I mean, I've always favored different brands, Klein or something like that, but this, to modify like this worked out pretty well. And what this is supposed to fit are these fasteners. So let me get everything clamped up and we'll take a look at this screwdriver working. Alright, so we got that on. This is our jaw, just like this. That goes on our studs, just like that. And then we have a nut. Then we have another nut, just like that, down in the bore. And we'll have our screwdriver come in, and hopefully, I don't know where that wants to tighten. There we go. That will bond them out right there. And this one, same thing. Get that started. So I probably didn't want to tighten that one first. Rookie mistake. There we go. I cocked it when I did that. So there we go, nice and snug. Go back down in this one. And nice and snug. So there we go. So now we have this mounted to our vise. We'll have our pin like that. if we wanted to test something there, because these load cells work with both tension and compression. So we can pull upwards and we can also squeeze. So we can use the vise handle to compress this. We'll see how much force we've exerted, and then we can also use the vise handle to unscrew. Now I wouldn't go crazy because I don't know how robust this vise is designed to pull apart things, but I don't think we're going to exert a whole lot of force to make these fail, and that's largely what this is designed for, so I think we'll be okay. If not, it's a $70 vise we destroyed. Okay, so here we go. You can see we got both jaws made up. You can see a little bit of that contour right there. We got the pins both in on both sides. So I think we'll call it for this episode. Next episode, we're going to pick up with wiring up the electrical parts and keep going with this project from that point. So if you enjoyed this, stay tuned. There's more coming on this vise, and you'll continue to see it in future episodes where we test stuff out. You may have already seen some other stuff on that. So, as always, thanks for watching, and have a great day.